Hello Year 12 and welcome to Purple Mountain Maths. We're doing the 2024 HSC paper for Maths Advanced. This is part 2, question 11, 12 and 13, worth 9 marks. Question 11. The graph of the function g of x is shown. Using the graph, complete the table with the words positive, 0 or negative as appropriate. Pause here to try yourself. Okay, so the first thing they asked us to look at is what's going on when x equals minus 3. I can see that at x equals minus 3 I've got a positive slope, so the first derivative of the function is positive. I can also see right there I am concave down, so I need to put in the word negative. Okay, let's now look at x equals 1. I can see that the slope is 0 at that point. I can also see that I'm changing from concave up to concave down, so the second derivative is also 0 at that point. And now let's investigate what's going on at x equals 5. I can see that it's a positive slope. I can also see that it is concave up, which means it's a positive second derivative. And that's my answer. Question 12. Find the sum of the terms in the arithmetic series as shown. Pause here to try yourself. Okay, so I'm told it's arithmetic, and I can see that that's the case because starting at 50, a equals 50, I'm adding 7 each time, so d equals 7. I don't know how many terms it's taken me to get to 2024, so I'll put Tn equals 2024, but Tn straight off the reference sheet is also a plus n minus 1d. So let's sub in those values. 2024 equals 50 plus n minus 1 lots of 7. 2024 equals 50 plus 7n minus 7, which is 43 plus 7n equals 2024. So 7n is the difference between those two numbers. So use your calculator. Okay, so put that in your calculator and you'll get n equals 283. So that's helpful. Now we can just use the formula for the sum given the first and last term. So it's 283 over 250 plus 2024. We'll get an answer of 293471. Question 13. The graph shows the populations of two different animals, W and K, in a conservation park over time. The y-axis is the size of the population and the x-axis is the number of years since 1985. Population W is modelled by the equation y equals a times 1.055 to the x, and population K is modelled by the equation y equals b times 0.97 to the power of x. So straight away I can see from the structure of those formulas that this is the one which is growing and this is the one which is decaying because the base value is either greater than 1 or less than 1. So this must be the line y equals b times 0.97 to the x, and this line must be y equals a times 1.055 to the x. Okay, so they're asking us to complete this table. We're told that the population in 1985, we're given that A is 34. So clearly that is this point here, A, and that makes sense because when you sub in x equals 0, you'll get y equals a times 1.055 to the 0. Anything to the power of 0 equals 1. So y equals a initially, and we're told that a equals 34. We're asked to find the value of capital B. That must be when x is 0. So if I sub in x equals 0 in this one, y equals b times 0.97 to the 0, I just get that y equals b initially, and I can read what that is. And I can see what that is from the y-axis. It's at about b equals 280. The other thing I could do is use this point here, the fact that the answer is 61 when x equals 50. So the fact that it has to go through this point, 50, 61, that reveals to me that 61 equals b times 0.97 to the 50. So b is 61 on 0.97 to the 50, which is 279.73, and so on. It's approximately 280 no matter how you do it. All right, let's fill in the other rows. Percentage yearly change in the population. I can interpret that from the structure of this equation. The fact that y equals a times 1.055 to the power of x, and x is as each year marches on, that's telling me that it's a 5.5% increase in the population of W. Similarly, I can see that the population of K is dropping by 3% each year. So I'm going to reference the dropping by making it negative 3%. All right, the last thing I need to do is find out the population of W at x equals 50. I'm going to use the formula. So at x equals 50, y must be 34 times 1.055 to the 50, and I will get 494.4266, so on. So it's approximately 494. So I'll answer 494. And from the context of this question, I can see that it makes sense to give an integer answer.